name is Andy Vaughn. I'm one of the test pilots on the Textron AirLand Scorpion. We're here today at RIAT in RAF Fairford, and this is our last stop on our European demo tour. Worldwide, there's A37s, F5s, OV10s that are aging out and need replacing. And with the heavy focus on the current modern ground commander and his need for intelligence and surveillance and reconnaissance, we developed the Scorpion from our own requirements rather than a government set of requirements. So we see the Scorpion as really fitting the role of an ISR multi-role airframe as its primary mission. And you can see that's reflected in the design of the aircraft with this fairly straight wing. And that's really for long endurance and slow loiter speeds. It's quite lovely to fly. It's very docile and it handles quite carefree. And I've really noticed that, for example, aggressive maneuvering down low or in the landing pattern, it's quite easy to fly. Flying final approaches is in the low 100 knot range. It stalls very slow in the 85 knot range. It can accelerate and fly in a faster regime. You know, it's quite maneuverable, I'll say, and it reminds me of my days when I used to fly the A-10 in the U.S. Air Force. We've been doing some flight demos with the RAF, the Test Pilot School, as well as some trials with the Royal Navy down at Royal Naval Air Station Cold Rose. In those trials, we have been testing a new sensor we've integrated on the Scorpion, which is the Thales iMaster, to validate our MMTI and our GMTI modes on that, as well as do some synthetic after radar images through weather, flying search and probe sorties with the Royal Navy's Sea Kings, searching for various ships and identifying different vessels out in the water up to 100 miles off the English coast. They were tremendously successful for us to validate the installation and the engineering work behind installing the iMaster onto the Scorpion in just a matter of weeks. Furthermore, we've been able to test our new mission system on the aircraft, which is developed by Force X. That's allowed us to test the iMaster on various modes, as well as using our L3 Westcam MX-15 DI. We're not tied to any one sensor. We want to be as flexible as possible, and we share that philosophy with our weapons as well. So Scorpion has the internal payload bay. We've got an area in the nose to carry a radar. We've got an area right behind that to carry another sensor. And then we have the 6 hardpoints on the wing to carry up to 1,000-pound NATO-class weapons. It is possible to install weapons into the payload bay and not have any external protrusions out on the wings. When we get back to the States, we're going to start integrating another sensor from FLIR Systems. That'll be the 380 HLD, in addition to the sensors we currently have on the airplane. We're going to do further mission systems software testing, and then we're going to start preparing for our first weapons demonstration. Our first weapons drop is likely to be a G-Claw, which is made by Textron Systems, and that weapon is an internal installation inside the payload bay and is dropped from a tube. You have the ISR and you have the multiple sensors and you have the flexibility to bring weapons, so you could have many missions with one airframe with minimal reconfiguration time between missions.